So today's topic is basically earthquake engineering. From very basic, if I ask you, what is earthquake? Anybody? What is earthquake? If somebody asks you what is earthquake? Yes, movement of tectonic plates. Now, in order to civil engineering domain, if we talk about, let's say this is the soil levels or the ground level, GL for any place, any geographical place. Somewhere here the earthquake, some tectonic plates movement has happened. So that will come straight away over here, which is called epicenter. Now from this epicenter, different places, the vibration goes. Now in terms of civil engineering language, there are two kinds of earthquake. One is static, another one is dynamic. Now we all know that earthquake is actually dynamic force. Then what is the point of asking static earthquake? So why this two part has been told by Indian standard? Why we need both the analysis? Why we can't directly go for dynamic? So the basic difference between these two is time period. Static analysis that we are doing is mainly based upon the different codal provisions. Dynamic analysis, we are not doing it manually. Once we have that model, then it would be very easier for us to do it. So this says that there is a term called VB bar. What is this VB bar? This is called base shear, right? So for an example, there is a structure. So there are different forces and there is a different resistance also. So if all the force we can make it a summation of F, we will not get the highest deflection at the base, we will get at the top. So force and resistance, in both the terms you can define base shear. Now when it is called static base shear, when we are formulating it as per the IS code. So in this H into W, there is a further formula of H, SA by G, I by R, Z by 2. All these things are there in IS 1893 part 1 2016. Different wall filling, whether it is infill wall of block work, brick work, fly ash brick work, whatever that kind of work, or it is a Maivan shuttering where there will be non-structural walls, or there will be different kind of glass facade, or it will be something else, let's say steel structure or composite structure. This entire thing is something which is static, which is not getting changed every time. These are the values which is static as per the codal numerical formulas. It is not dependent upon the model that you have done, because you have put it from the code. It is a fixed formula. But now in case of dynamic, okay, so the first mode, first time period that you are getting, that is basically the dynamic time period. After going there, you are putting Z value, you are putting I value, you are putting R value, but you don't put any kind of time period over there. Generally, dynamic base shear should be always lesser than static base shear. Why? Now you will be able to understand why static analysis is required to be done. But make sure that stiffness that you have modeled, that has to be dot to dot same at the site, and we generally match it with the static base shear. If tomorrow somebody asks you anything about static and dynamic analysis, you should be answering it with full confidence. Once the topics are little bit in advanced side, it would be definitely helpful. But the point is, it will not be helpful if you do not read the code along with this. Understood? Any doubts regarding this part which I have told? Alright then, thank you.